Okay, solving square roots with prime factorization. So first of all, a little introduction. If we take a square with side lengths of 3, what is the area? Well, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that the square root of 9 is 3, or 3 squared equals 9. Our two relationships. It's called a square root because we're taking the area of a square 9 and square rooting it to get the side length, or we are squaring the side length to get the area. So let's do a potential question like the square root of 4. Now anyone who already knows the answer, we're just doing the process to build up and do higher level questions. So we're going to take 4 and we're going to do a prime factorization tree, and that's 2 times 2. And then we're going to write the square root of 4 a little differently. We're going to write it as the square root of 2 times 2. And I'm going to read an English sentence. If we have two identical numbers underneath the square root, one comes out and there's just nothing left, equal to 2. We can take out our calculator and we can square root 4 and we can get 2, and we can circle our answer and check our answer as always. Keep in mind, we could have just thought, what are two identical numbers that multiply together to get the number underneath the square root? And 2 times 2 is 4, so we know the answer is 2 for all sorts of reasons. Let's take a look at another example. Square root 36. So I'm going to take 36 and I'm going to do prime factorization. Now, the order doesn't matter. You could do 12 times 3 or 9 times 4 or 18 times 2. Let's do 6 times 6. It's going to make our tree flatter. So 6 is 3 times 2. And again, 6 is 3 times 2. And then we're going to write the square root of 36 as the multiplication of those numbers in ascending order. So, as we learned previously, I'm going to read another English sentence. Two identical numbers underneath the square root, one comes out. Two identical numbers underneath the square root, one comes out. And we multiply these numbers together to get 6. Again, on the calculator, square root 36, we're going to get the answer 6. Also, check in your head, 6 times 6 better be 36, of course. Okay, so again, keep in mind we could have just thought about two identical numbers that multiply together to get the number underneath the square root. Of course, we could have just stopped right here. But again, we want to do higher level questions in the future. So let's take a look at the square root of 81. So again, we know the answer is 9, but we're doing it properly. So I can take 81 and I can do a prime factorization tree and I can get 9 and 9. Now, again, as you can see in the notes, I have continued to go with 81 and did all the same steps as 36. But either way, remember, all I'm looking for is two identical numbers that multiply together to get the number underneath the square root. 9 times 9 is 81. Therefore, the square root of 81 is 9. Get your calculator out. Square root of 81 is 9, or 9 times 9 equals 81. Check mark. So we are doing prime factorization, then writing the numbers that multiply to get those numbers underneath the square root, and then looking for identical pairs. Once we found a pair of numbers, we circle that pair of numbers, and that number is now on the outside. Usually all the pairs of numbers will be circled in grade 8, and we will worry about mixed radicals in grade 9 and grade 10. But outside of that, this method is going to allow us to do much more difficult questions. For example, not in the notes, but let's take the square root of 162 equals what? Well, another method is called perfect squares. What are two identical or two numbers that multiply to get the number underneath the square root, that you know the square root of one of them? Well, we know that root 162 is simply root 81 times root 2. 81 times 2 is 162, so we can separate the root into a multiplication of two roots. Now, 81 is 9, so it's simply 9 root 2. And we probably won't do those things until we get to grade 10, just getting ahead. Square root of 162 is 12.7. So I'm just going to say that, 12.7. And then I'm going to do 9 times the square root of 2. And I'm going to get the same 12.7. So we can say check mark for any of the students who are getting ahead. Great. Okay, now let's take a look at solving cube roots. So another real life example. Let's take a cube again with side lengths of 3. And learn about the basics about cubes. Looks better in the notes. Okay, so we know that this is a cube that is 3 by 3 by 3. And we know that 3 cubed is equal to 27. And the cube root, notice cube root is signified by the tiny little 3 equals 3. 3 times 3 times 3, or 3 cubed, is 27, and the cube root of 27 is 3. Notice, on the last page, none of these questions has a tiny little 2, but lots of times they do put them. A 2, a 2, a 2, a 2. Reminding you that we're looking for 2 identical numbers underneath the square root, or 2 identical pairs of numbers underneath the square root, where now we're looking for 3. So let's take a look at the cube root of 27 using prime factorization. So the cube root of 27 equals. So we'll take 27 and we'll do prime factorization, 3 times 9, and 9, 3 times 3. And then we'll write the cube root of 27 equal to the cube root, of 3 times 3 times 3. Now, 3 identical numbers underneath a cube root is just equal to that number. And again, you can check your answer. Make sure you understand how the calculator buttons work on your calculator. For example, this calculator, I press 27 and then I take the cube root. That is the same as the process on the iPhone. However, some other calculators, you press the cube root and then 27. So make sure you are comfortable with your calculator before the test. Outside of that, 3 identical numbers that multiply to get the number underneath the cube root is the answer. And to check your answer, 3 cubed is 27, or on the calculator, obviously. Okay, let's do the cube root of 64. Keep in mind, that tiny little 3 has to be really small, right about there. So let's take 64 and let's do prime factorization. So feel free to use your calculator for this division. Outside of that, use your multiplication tables. 64 is 8 times 8. And 8 is 4 times 2. And 2 times 2. And again, 4 times 2. And 2 times 2. And then we can write the cube root of 64 as the cube root of a product of all the factors, all the prime factors at the bottom. Sometimes if it's confusing, it helps to circle all of the numbers at the bottom only. So we get 2 times 2 times 2 times 2 times 2 times 2. And you could check that on the calculator. 2 times 2 times 2 times 2 times 2 times 2, or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Therefore, 2 to the 6 is 64. We're doing cube roots. So again, I'm going to read an English sentence. We're looking for 3 identical numbers underneath the cube root as we did before. The tiny little 3 is the reminder. So we're looking for 3 identical numbers. Again, 3 identical numbers. If we have 3 identical numbers underneath the cube root, because 2 times 2 times 2 is 8, and the cube root of 8 is 2, 3 identical numbers underneath the cube root makes 1 on the outside. If we have more than one circle, we bring that out again. So the first 3 2s as one circle comes 1 2. The next circle of 3 2s becomes another 2 on the outside. And 2 times 2 is 4. And we can check that answer on the calculator. The cube root of 64 is 4, and we can also do 4 times 4 times 4 is also 64. All sorts of reasons. We could have just thought, what are 3 identical numbers that multiply together to make the number underneath the cube root? For example, 4 times 4 times 4 is 64, and we could be finished with it. So that's prime factorization. There are other methods called perfect squares methods. For square roots and for cube roots. A little bit more difficult. You might learn those methods. Feel free to use those methods if you like. I will show 2 brief examples of those. So one example will be the square root of, let's say, you know what? Let's wait until grade 10 for those. So if you do want to get ahead, feel free to take a look at the grade 10 mixed radicals if you are going to be doing those calculations earlier in grade 8 or grade 9. So again, keep in mind, use your calculator to check the answer and have a good foundation about the definition of a square root, the side lengths of a square with that area, or vice versa. The area would be the side length squared square root, and the foundation of a cube. The cube root of the volume is the side length, where the side length cubed is the volume. Now we're going to use this to help us solve square roots in the rest of math, but specifically Pythagoras' theorem.